All right, I had assignment number 19, which dealt with the comparison test. If you're like me, this was a topic which was hard to grasp at first, so hopefully this gives a nice review. My first question was, determine if the series from n equals 1 to infinity of cosine squared of n over n squared plus 1 converges or diverges. In order to solve this problem, you have to have knowledge of the theorem 11.4.1, which is a direct comparison test, which says, if the series of a sub n and the series of b sub n are series with positive terms, then if the series of b sub n is convergent and a sub n is less than b sub n for all n, then the series of a sub n is also convergent. Or you have the vice versa almost of, if the series of b sub n is divergent and a sub n is greater than b sub n for all n, then a sub n is also divergent. So the trick to this is picking a good series to compare with. So we choose to compare with 1 over n squared. Why do we choose to compare with this? N squared is less than n squared plus 1. So we know 1 over n squared plus 1 is less than 1 over n squared. So this cosine squared of n over n squared is greater than cosine squared of n over n squared plus 1. That doesn't change anything. So we know that if you pull the cosine squared of n out, times 1 over n squared converges by the p-series test. We look at the p-series test in review, which is if the series of 1 over n to the p converges if p is greater than 1 and diverges if p is equal or less than 1, and our p-value is 2. So we know that this converges by the p-series test. So cosine squared of n times 1 over n squared plus 1 must converge as well, which is the exact same as our function at the top. So in conclusion, it has to converge as well. So then the second part of my question dealt with a true or false, and it was analyzing the series of n equals 1 to infinity of 1 over n to the 3 halves. So it was the same idea. You had to say if it converges by comparison test with the series of n equals 1 to infinity of 1 over n squared. So you do the same steps. So you have n squared is greater than n to the 3 halves. And if you change it to 1 over n squared, it's less than 1 over n to the 3 halves. It's the same one as last problem. We know that 1 over n squared converges by the p-series test, but we can see that it's smaller than 1 over n to the 3 halves. And if we look back at our theorem, that's not what it says. It doesn't work the vice versa way. So this would have had to been bigger than n to the 3 halves, and then it would converge. But since it's smaller, this can converge, and this function could not converge since it's bigger. So this leads our answer to be false with comparison to the 1 over n squared. However, by simple p-series test, if we wanted to solve this out anyways, we know that the series of n equals 1 to infinity converges by the p-series test because our p is 3 halves, which is greater than 1, and that means it converges. And that is the end of my assignment. Hope this helped.